Let's go over the sample final for Calc 2 here. And it says this is a velocity table and this is the time. So the area under the velocity would be the distance, and it asks us to find the velocities are in meters per second. Use a trapezoidal rule to find the total change in the distance of the object over 10 seconds. Now, we spent a lot of time doing left and right, and I might make it the actual test, have the left or right ones, but the trapezoidal, it, just a quick note here, if this is the velocity time graph, and if at 0 seconds it's at 2.5, and at 2 seconds it's 2.3, the trapezoidal rule would say find the average height times the width to find the area in that section. So 2.5 plus 2.3 divided by 2 is 2.4 over the time interval of 2 seconds. And each one of these is 2 seconds, so I can just take 2 times the end here, plus the average height between 2.3 and 2.1. The average height would be 2.2. 2.1 and 1.7, the average would be halfway between, which is 1.9. And between these two, it would be 0.9 and 1.7 is 1.3, I believe. That's 4 down from there and 4 up from there. Yep. And halfway between here would be plus 0.6. So this would be 4.6, 5.6, 6.5, 6.8, 7.8, 7.8 plus 0.6 is 8.4 times 2, if I haven't made a mistake, is 16.8. And this was seconds, and the other's in meters per second. So meters per second times seconds, which is 16.8 meters, is the change in the distance. Okay, number 2, find the average value. Well, the average value is the average height, which is be the integral on the interval from 0 to pi over 2 of sine of 2x dx. That'd be the total area. Then if you divide it by the width of the interval, which is pi over 2 minus 0, this would give you the average height. The total area divided by the width gives you the average height, the average value. All right. So 1 over pi over 2 minus that is 2 over pi. And now we got to integrate sine. So the integral of sine is negative cosine. And this would be 2x, but then the derivative would create a 2, so we have to divide out the 2. So the derivative of negative cosine of 2x would be sine of 2x times a 2, and this divides out the 2 to make us that. So we've got to evaluate that from 0 to pi over 2. And so if we put pi over 2 in here and take it times 2, we get pi. Cosine of pi is minus 1. So minus and minus 1 is 1 over 2. 1/2 of 2 over pi is 1 over pi. Minus put 0 in there. Cosine of 2 times 0 is 0. Cosine of 0 is 1. So this would be minus 1 over, let's see, that's 1 and a minus over 2, so it's 1/2. So we'd be taking 1/2 times this would be 1 over pi. And let's see here. Did I get the signs right here? So I'm subtracting, and if I put in 0, I get minus, because this is plus 1 over that, minus 1/2 times that's minus, so this becomes 1 over pi plus 1 over pi, which is 2 over pi. Okay, so now we have an even function, and it has these two values. So an even function, is symmetric with the y-axis, and from -2 to +5, the total area is 7. So whatever's here repeats here, and then there's some more over here. So the total of this is 7, but from 0 to 2, and that's in the correct order, 0 to 2, is 3. So that means there had to be 3 here if it's even, which means this has to be plus 1 out here. So this thing must do something like this, where it gets big in here and smaller out here. So it's 1 over here, 3 and 3, that's a total of 7. And it must be another plus 1 over here from -5 to 2. -2. So from 2 to 5, 2 to 5 is plus 1. From -2 to 2 is plus 6. And from -5 to 5, it's 4 and 4, 8. Okay. Find the indefinite integral here. So this is a fairly simple one. This would be the integral of x to the 5th plus x to the -2 dx. And using the power rule, this becomes x to the 6th over 6. And doing this one, adding 1 to -2 is -1, x to the -1 over -1 plus c. Rewritten, that's 1/6 x to the 6th minus 1 over x plus c. Page 2. Use fundamental theorem of calculus. That's basically find the difference on this. So we integrate this. So this is the integral from 1 to 3 of 3 times 1 over x plus x squared minus 2 dx. So the integral of 1 over x, even though it's times 3, is just 3 ln x, and 1 over x, or x to the -1, that's always ln. But anything else, if it's not -1, then it's not ln. Integral of x squared is x to the 3rd over 3, and then minus 2x. Evaluated from 1 to 3. We didn't change the value of x, so same limits, and so we get 3 ln 3 plus 27 divided by 3 is 9, minus 6 That's putting in the 3's, minus, put in the 1's. ln of 1 is 0 times 3 is 0. Plus 1/3 minus 2. So we got 3 ln 3. And then all this can be put together here. So we've got 9 minus 6 is 3. Minus 1/3, which is 2 2/3. Minus 2, so it'd be just plus 2/3. So doing it another way here, 1/3 from minus 2 is minus 1 2/3 added to the 3 leaves minus 2. Oh, yeah, I did make a mistake here, so I'm going to check this here. So this is 3, and minus 2 plus 1/3 is minus 1 2/3, and minus and minus is plus. So we got plus 1 2/3 plus 3, so that's 4 2/3 plus 4 2/3. All right, next one. The integral of secant squared is tangent. And the integral, this would be x to the 5/2 with a negative on it. And the integral of that would be, add 1 to this, so that'd be 2/2, so that'd be 7/2 times 2/7. So minus 2/7 x to the 7/2 plus c. All right. So remember, when this is a velocity graph, and this is velocity, it's in feet per minute, and horizontally, this is the minutes. So the area under the curve is how far that one travels, the change of distance. And so the distance between them would be how much area is between these two. So if this is 2 feet per minute and this is in 2 minutes, then 2 feet, this would be 4 feet. One box would represent 4 feet. Well, if this is a race, they start off at the same place, so I'll just make my x-axis here, and I'll make this 2, 4, 6, 8, 10. I hope that's enough. Let's see. How much distance is between them by the time we get to here? They were together here, and so I need the area of this to find out how much distance there is between them. Well, if these were full boxes, that'd be 4, that would be 8. But this is a little less, so it's about that much less. So this is 4, 5, 6, 7, maybe 7 between them. I'm afraid this might not be enough. So I'm going to go 4, 8, 12, 16, 20, 16, 20. So, and I'm going to make the same timeline as above, match it. And so after 2 seconds, the distance between them is 7. 0 at the beginning. Now this is going to add some more distance to between them. So if I take the average height there and the average height there, that looks like 2, 4, maybe 5 more than 7. That'd be about 12. And then here, the average and the average, that looks like about not a full square, maybe 3 out of the 4 of the square, so 3 more. So that'd be to 15. And then in here, the average and average, maybe 1 more, so maybe 16 by the time I get to there. Now the other one's ahead, and so this might take off. Looks like about a half of one. Then here it looks like about I don't know, not quite two, 1.5 off of that. So if I'm a half down from 16 and do another one, that's 2 down from 16 from here to here. And then this looks like about, maybe 3 more down. So that would put us down to here. Then this would be another almost 4, 3.5 down. That put us down to here. And this would put us down 4 and maybe 5 below that. So that'd be about here. And then this would be 4, 5.5 more down. So that would put us down 4, 5.5, somewhere about there. So here's the graph of the distance between them. And if the dashed line is Harry, this is Harry, and the other one is the slug or snail, who is ahead at 20 minutes? It looks like the snail has finally taken the lead and probably about 2 feet ahead. This is what my graph came out to be. So the snail by 2 feet and 20 minutes. So it's just an exercise in calculating the distance, the change in the distance, looking at velocity graphs. Okay. Do substitution on this one. Well, it looks like if we let u equal 1 minus 5x squared, du would equal minus 10x dx. dx would be du over minus 10x. So this integral will become the integral of, well, we haven't taken care of that x, but this is going to be the square root of u, and dx is going to change to du over negative 10x, and the x's cancel. I can take out the negative 10 in the denominator, and I'd have the integral, and this is like in the denominator, so this would be u to the negative 1/2. So adding 1 to negative 1/2 is plus 1/2, and times divided by the 1/2 would be 2 u to the 1/2 and 1 over negative 10. So that's negative 1/5 square root of u, but u was the 1 minus 5x squared plus c. Integration by parts. So if I let u be the x and dv be the e to the 2x dx, this would be 1/2 e to the 2x. And this would be just dx. This is the derivative row. So this becomes u times v, so that's 1/2 x e to the 2x minus the integral of not these two that we started with, but those two, 1/2 e to the 2x dx. So this becomes 1/2 x e to the 2x minus, this would be a half. The integral of e to the 2x is 1/2 e to the 2x plus c. So it's 1/2. Well, there's e to the 2x in both of these, so I could factor it out. So this would be 1/2 x minus 1/4 e to the 2x plus c. By partial fractions. All right, so this factors to x plus 1 and x minus 1. No repeating, they're all single factors, so this would be a over x plus 1 plus b over x minus 1 equals 3 over x squared minus 1. So to get a common denominator, I'd have to multiply this one by x minus 1 on the numerator and denominator. And this one by x plus 1. So if I look at just the x's, looks like there's no x's over here. And over here I have a of them. And here I have b of them. Then if I look at the constants, I have 3 here, and here I have minus a, and here I have plus b. Well, looks like the a's will cancel if I just add these two, and I get 3 equals 2b, so b equals 3/2. And if a plus b is 0, a must be negative 3/2. So this integral changes to the integral of negative 3/2. The a could come out of 1 over x plus 1 dx plus the b can come out, and that's 3/2. The integral of 1 over x minus 1 dx, which is minus 3/2 ln. And there's no number in front here, so we don't have to divide by anything. And then plus 3/2 ln of x minus 1 plus c. It says evaluate if possible, show the proper steps. So, well, we have the problem here. E to the 0 is not a problem, but e to the infinity might be. So we say this is the limit as a approaches infinity of the integral of 0 to a of e to the negative x dx. We integrate. I had a little trouble drawing that time. And that would be negative e to the negative x evaluated from 0 to a. So we have the limit as a approaches, let's see if I can do this better that time, there we go, of negative e to the negative a minus a minus, so it'd be plus e to the negative 0. Well, e to the 0, negative 0, 0 is 1. And if e is going to negative infinity, e is getting smaller and smaller and smaller as you go to negative infinity. Negative makes it 1 over e to the infinity, which that fraction is going to go to 0. And so this is going to be 1. Okay, using trig substitution. So a squared minus x squared. Well, let's get this to be just a u. So I would use u equals 9x du would equal 9dx. So this integral would change to 1/9 the integral of du over square root of 1 minus u squared. So it's an a squared minus x squared look. When it has that, we do u, or x, but now it's u, equals a, which is 1 sine of an angle. Figure out du would be cosine of the angle d theta. The picture would look like the angle and the sine is u opposite over hypotenuse over 1. So this side be 1 minus u squared, which is the cosine. So cosine of theta would be the 1 minus u squared, square root. So the integral would change to 1/9. Du would change to cosine theta d theta. And the square root is cosine theta. So the cosines cancel. And so we get 1/9 theta plus c. Changing theta back into u's. See, that would be the sine inverse of u. And changing that back into x's, that'd be 1/9 sine inverse of, see, u was 9x. All right, the final page. This looks like it might be integration by parts. It doesn't look like it's going to be easy with that sine squared. So let's give this one a whirl. All right, so I think we want that to go down. So we're going to let u equal x. So the derivatives are then, this would be just dx. So everything else has to be in the dx. So sine squared x dx is going to be dv. So what is v? Well, if we look at our table of integrals, we see, let's see, where do I have it? Hang on. Look for that. So if we look at our table of integrals, we can see that the integral of sine squared is this, or there was one with the sine of 2 theta, but we'll go with that one. So that's x over 2 minus 1/2 sine x cosine x. So this would change to uv. So that'd be that times this would be x squared over 2 minus 1/2 sine times x. So x over 2 sine x cosine x, that's the UV, minus the integral from 0 to pi over 2. By the way, we have to evaluate this from 0 to pi over 2 of these. So this would be x over 2 minus 1/2 sine of x cosine of x dx. Okay, so this would be, let's just figure this part out, get this taken care of. So this is pi squared. When I put pi over 2 in there, that's pi squared over 4 divided by 2, so it's pi squared over 8. And then we're going to have pi over 4. And sine of pi over 2 is 1, and cosine is 0, so that's going to be gone, so we're going to get nothing from that. Then if we put in 0, that's gone, and this would be gone, so we're getting nothing from that. So all of this is just pi squared over 8 minus, minus this integral of this stuff. So I'm going to write it down here again. So we got pi squared over 8 minus the integral of this first part is going to just be x squared over 4. We're going to have to evaluate that between 0 and pi over 2. And on the second part, we got minus a minus, which would be plus the integral from 1/2 integral from 0 to pi over 2 of sine x cosine x dx. Now this is going to be pi squared over 4 divided by 4. So that's pi squared over 16, and that would be 0. So we got pi squared over 8 minus pi squared over 16, which is just pi squared over 16 altogether. But this part, we need to either let u be sine x or cosine x. I'm going to let u be sine x. Then du would equal cosine x dx. And dividing by cosine x, I get this, which is pi squared over 16, because an eighth minus a 16th is a 16th, minus 1/2, and this will be the integral from 0 to, changing it here, so sine of 0 is 0, so it's still 0, and pi over 2, so you would be 1, because sine of pi over 2 is 1, of, in place of the sine, I have u, and then I have cosine x, and then the dx is du over cosine x. So integrating u, I get u squared over 2. So we got pi squared over 16 minus 1/2 of u squared over 2, evaluated from 0 to 1. So this is pi squared over 16 minus 1/4, and 1 squared would be 1, so that'd be minus 1/4. Then putting in the 0, I get nothing, and so this is my final answer. Consider the area bounded by y equals the square root of x. That would look like square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, sideways parabola, y equals 2, and x equals 0. So we're looking at this area because that's the part that's bounded by that. Spun around the x-axis. So its mirror image down here would be here. Find the volume of the solid. Well, let's do disk method and shell method. I think the shell would probably be the easier, but I'm going to do disk to start with. So I have the large radius, that the center line is here, and the distance to the outside is always 2. So it's pi integral from, and see, the slices are going to be dx's. So the x goes from 0 to 4. The large radius is going to be from 0 to 2, which is 2 squared, minus the small radius is going to be from here to the curve, which is just y squared. But since I have to do dx, I'm going to change the y to the square root of x squared, which is just x. So I have 4 minus x. So I have pi integral from 0 to 4 of 4 minus x dx. So this is going to be actually pretty easy, and this one turns out to be pi 4x minus x squared over 2, evaluated from 0 to 4. So I got 16 minus 16 over 2, 8. 16 minus 8 is 8 pi. If I put in zeros, I get nothing. Let's do shell method. So if I'd made a slice this way, it would be dy, and it's 2 pi. The radius would be just y. That's how high it is. Up is y. And its length would be out to whatever x value that is. And dy would go from 0 to 2. And y is equal to the square root of x, so this would be 2 pi integral from 0 to 2 of the square root of x, which is x to the 1/2 times x, which would be x to the 3/2. Oop, I need to do y. This would be x is y squared. I have to square both sides. So this, I want to do this as x turns into y squared. So this would be y to the 3rd dy, which would be 2 pi. Y to the 3rd would be y to the 4th over 4. Evaluated from 0 to 2. 0 is not going to give me anything. 2 is going to be 16 over 4, which is 4, times 2 pi, which is 8 pi. And finally, climber is pulling up a 40-pound pack and a rope that's 2 pounds per foot. That's a heavy rope. And you got to pull it up, and it's 150 feet. So that's a 300-pound rope. Whoa. Amazing that they can do that. So that's probably ridiculously too heavy rope. But anyway, that's what I made up, so we'll go with it. And they're going to pull it up, and the pack weighs that. So two ways to think about this. Actually, several ways to think about it. But let's just say, got to lift the 40 pounds the whole distance, and work is force times distance. And pounds is a force, so we don't have to do any density stuff or anything like that. And so just to lift the backpack up there, it's going to be 40 times 150, and that would be the work for the backpack. It's taking care of it. The backpack stays the same all the way up. Now when we think about the rope is 150 feet times 2, that's 300 pounds. But as soon as you start pulling up a little bit, it gets less in weight. So we can either figure out how much less it is in weight, because it's going to be less in distance, which we would then say, so by the way, 150 times 4 is 6,000 joules. Is that right? 1,500 times 4, 3,000, 6,000. So this is 6,000 joules for the backpack. So we're going to have to add 6,000 to our answer. Now for the rope, we can say the length that's still down there, let's say that is a length of y. That length times the weight per foot, so times 2. That's the weight that's down there, times the distance we're going to move that length, a small amount, and then we're going to, once we move it that small amount, the length gets a little smaller, times 2, times the small amount we lifted, times 2, times the length that's left, times the small amount we lifted, and we add up all those from 0 to 150. That's one way to figure out the rope. The other way is to say there is a small section of rope, the length is dy, and 2 times dy is how much that small chunk of rope weighs. 2 pounds per foot times a small amount of foot, and we have to lift it a y distance all the way to the top. Notice they're the same thing. There's just two different ways of thinking about it, but they come out to be the same mathematically. And the integral of 2y is y squared, evaluated from 0 to 150. So we're going to have 150 squared minus 0, so is 22,500 joules of work to lift the rope, plus the 6,000 for the backpack, so it's 28,500 joules of work total.